You can use this video to correct your work on your number systems worksheet and to make sure that you're ready for our quiz coming up in class. In number 1, we want to convert a decimal value, a base 10 value, to 8 bits of binary numerals. So we could think how binary numbers work. All number systems begin with a ones digit, and then we do powers of the base. So this is 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth, 2 to the fifth, 2 to the sixth, and 2 to the seventh. And that would give us our 8 columns. 83 is not going to require all 8 columns because we can't get any groups of 127 out of 83, but we start with a 1 in the 64 column. So whether or not you put a 0 in the leading column is really up to you. All right, so now we know that we're starting with 83. You might do some scratch work over here, and we've already done a digit here for 64. So we would subtract here, and we'll find out that we have 19 yet to cover. So I have 0 groups of 32, but out of 19 I can do 1 group of 16. And then of course you can see that we have 3 left over, so we can get no 8s, no 4s, but we can take a 2, and I don't think you have to show this subtraction anymore, but that's one method that would work. So this number right here is our binary equivalent. In base 2, this number is equivalent to 83 in base 10. Okay, let's try another one. The next one is to convert 90 into binary. So I'm going to do that same thing. Now you might not have to write these numbers each time, as long as you know that these are your place values. And we're starting with 90, so again, no groups of 128, that 0 is optional, but I can get a group of 64 out of there. So I'm going to subtract to find out what's left, so I'm going to borrow, of course, here. So we will have 26 yet to cover, if my arithmetic is correct. So 0 groups of 32, but we can use a group of 16. And then we would have 10 remaining. So from that I can do a group of 8 and a group of 2. So once you get to a small enough number, I hope that you can just fill those in. So there's our answer. And one more, but this time our number is 64. And do you recognize that that is one of our powers of 2? So 1 group of 64 takes care of it. Everything else would be zeros. Everything else would be zeros. So hopefully you can do that one kind of quickly. And the next example, 255, I also hope that one is fairly simple. If you realize in our binary system, let's write these powers again. 128, and then what would be the next one? 256. A little bit off my edge here. Well, look at our number 255. It's 1 less than 256. So this is the biggest number that we can represent with 8 bits. So perhaps you already know that this will be 1s all the way across. Let's say you hadn't recognized that 255 is just 1 fewer than 256. Then you would proceed the same way we have. So I know I can start out with 1 group of 128, and let's find out what our leftover is here. 127. Do you notice it's just 1 less than the power of 128? So now we can of course take out 1 group of 64, and when we subtract, notice now we have 63. It happens to be 1 less than 64. So now we're going to use 1 group of 32, and then we still have, whoops, let me try subtracting that correctly. And again, you can kind of see a pattern here, so we always have 1 less than just this value. So I'm going to have 1 group of 16, and now I still have 15 remaining, so I'm going to take a group of 8, and I still have 7 remaining, so I'm going to take a group of 4, And now I'll have 3 remaining. And of course, we can take a group of 2 and still have 1 remaining. So we'll have an 8-digit number, all ones. And that, if you can remember this, that this is 255 because it is 1 less than the number 256. So 256 would not fit in 8 digits. 256, we would have to roll over to the next digit of 1, and then we would have 8 zeros behind it. So hopefully you're noticing a pattern. Okay, we had one more step to go in our directions. It said, then can we change this to a hexadecimal numeral? Well, in a hexadecimal numeral, the shortcut here is that each group of 4 binary digits in 16 becomes 1 digit in hexadecimal. So each of these becomes the maximum value. So 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. That's our maximum digit. Remember that we use the letter F. So our digits run out at 9. So for 10, we change it to the digit A, 11B, 12C, 13D, 14E, and our biggest digit in hexadecimal is 15, and to represent it, we use the letter F. So we know that this is our hexadecimal number. FF is equal to the number 255 in base 10. Okay, now let's work in the opposite direction. So now we're given a binary number, and let's convert it back to decimal. And I don't have much space here, so I think what I'm going to do is first write my binary place values like we were on the previous page. And now underneath I'm going to stretch out to this number. So this is what was given, 0, 1, 1, 0, 1, 0, 1, 0. So now, and again, once you're familiar with these, you don't have to write these place values. But for beginners, we just want to be a little familiar with this so you don't have to become an expert. So we have one group of 64, we have one group of 32, we have one group of 8, and we have one group of 2. So we can add it up and see what decimal value we come up with. And it looks like we have 106. I better check my arithmetic here. 10, 12, 16, carry the 1. So we get 106 in base 10. And again, if I make an arithmetic mistake here while I'm talking through these problems, hopefully you'll at least understand a method for doing these. Okay, same idea in the next problem. Let me again, and feel free to do this. You could use the same group you have up above. Now we have a 1, 1, and then all the way zeros until we get to that last value. So what do we have here? We have a group of 128, we have one group of 64, and we have a 1. So let's add them up here and see what we have. 13 will carry a 1. So I think if my arithmetic is correct, 193. All right. Now a hexadecimal number, let's convert it to base 10. So now our place values, don't bother with binary. Think what base 16 is. This is the 1's digit, and this is the 16's digit. So in hexadecimal, our first digit is the 1's, our next is 16 to the first power. The next column would be 16 to the second. 16 times 16 is 256. Remember problem 4 from before? Okay, so what does this tell us? This number is 7 groups of 16. So 7 groups of 16, let me multiply that in decimal. 7 times 6 is 42. So we'd have 112. And we have C units. Well, what was the letter C? Remember that A was our digit for 10, B for 11. So C is our digit for 12. So this is 12 groups of 1. So our total here, when we add up our number, is 124 for our answer. So 7C in base 16 is equivalent to 124 in decimal. Okay, number 8, hopefully you could do that quickly. We've seen that in problem 4. What happens if we have 4 ones? Well, remember that when we filled all of these up, this is 1 less than the next digit. So if you think of the odometer in your car, in binary, if this was a binary odometer, the next mile you traveled, it would roll over to the next digit, and we'd have 1 followed by 8 zeros. So you might remember and just be able to write the answer here that this is 255. But if you didn't, let's go through the long way again. This is really the same question as question 4, just in reverse. But let's make sure you understand either of these methods would work. So we've got all 1s. So we'd have to start adding it up. We have a 128 and a 64 and a 32, a 16, 8, 4, 2, and 1. So you could add up your entire list. So there's an alternate method if you didn't recognize that question 8 was the same as question 4. So 255. So, and as long as we're remembering this, so 255 in base 10 was 8 ones in binary, and it was FF. Remember that each of these groups of 4 gave us a letter F in hexadecimal. So you can see that if you did these number systems often, it wouldn't be so hard to do them a little more quickly. All right, so now we're going to use our ASCII code. And remember that for the printable characters in our Western alphabet, ASCII code and UTF-8 codes will give us the same letters. So what do we want to do here? We want to take each of these and split them up. And I'm going to add a 0 here, so this is 4 digits and 4 digits. And I'm going to convert these to hexadecimal. You could convert them to decimal values, but I think we've seen that converting to hexadecimal is fairly simple. Let's see if we can do it without writing the numbers on top. So if I take just this group of 4, this is the 1s, 2s, 4s, and 8s. So do you see that that is the number 4? And this group of 4, this is 1s, 2s, 4s, and 8s. So that's a 2. And the hexadecimal, so I should label this. This is our hex column. If I could get my H crossed, I'm right at the edge of my videos, why that's causing me some trouble. So this is our hex value. Now let's go to your ASCII code table and go down the hex column and look for 42. And it is a capital letter B. That is the ASCII code for capital letter B. Okay, then let's go to the next. And again, I'm going to split it up into 4 bytes and 4. So I'm going to fill in a 0 here. So this first group, this is a 1, no 2s, a 4, no 8s. So this is a 1 and a 4, so that's the number 5. And here we have a 1, no 2s, no 4s, but 1 8. So 8 and 1, that's a 59. And let's go to our ASCII code sheet. And 59 is the code for the letter capital Y. And let's go to our next one. Let me switch colors here. And this is only 7 digits. So again, I'm filling in with a leading 0. So here we have a 1, no 2s, but we have a 4. So there's our 5 again. And this one, we have no 1s, no 2s, but we have a 4 and no 8s. So we get 54. And we look on our ASCII code sheet. And 54 is a capital T. And one more. Let's see what we've got here. And I think we've seen some of these before. This was, remember, no 1s, no 2s, but we have a 4. This one has a 1, no 2s, but it has a 4. So this was 5. So 45 Going down, make sure you're using the hex column, so make sure you can read your table. That is a capital letter E. So look at what we came up with. So in ASCII code, this was the word byte. Okay, number 10, of course, answers will vary since you are to use your 3 initials. So I'll do a sample problem, but of course yours will look different. All right, let's say my initials were DOS. Okay, so we're going to do a couple steps here. First, let's find the ASCII values, and let's use capital letters, by the way. Lowercase characters have different ASCII values. So I'm going to the hex column. So D is 4, and capital O is 4F, and capital letter S is 5, 3. And we want to convert these then to their binary codes or their binary values. And remember that each of these hex becomes a 4-digit. So instead of doing the larger numbers, you can just from hex to binary, it's 1 digit matches up with 4 digits. So you could go a little quicker here. So I'm thinking of the 1s, 2s, 4s, and 8s column. 1, 2s, 4, and 8 column. So for the digit 4, these will both be 0, 1, 0, 0. 0, 1, 0, 0. And I've got another 4 here. So that's going to be another 0, 1, 0, 0. And the letter F, I hope that maybe you don't even have to think about this. Do you know that it's going to be our maximum? F is 15. F is our highest digit, so I know it's 15. And 15 is an 8, a 4, a 2, and a 1. It's the maximum we can do with 4 digits. And then let's do the number 5. And again, you might want to think about the place values, 8, 4, 2, 1. So to get a 5, we need a 4 and a 1. So 0, 1, 0, 1. And for a 3, let's do one more. With our place values for a 3, we need to fill in a 1 in the 2 and the 1 place. So, of course, for your initials, you'll come up with a different value here.